All right, all right, all right. My people, let's go straight to KZN. Let's go straight to KZN. This question paper was written in KZN, actually by learners KZN. Common test June 2024, grade 11. Let's try to answer all these questions. Actually, the focus here, it will be gray. No. The focus here, it will be analytical geometry, right? After doing this analytical geometry, I will move to Free State analytical geometry, Limpopo analytical geometry, as well as Mpumalanga analytical geometry. So this is what I will be doing today, guys. So please stay tuned. Let me see. Yeah, okay. Let's go straight to analytical geometry, guys. People, please, make sure that you write the correct maths. Write the correct maths, and you get a distinction. You move to the next level, just like that. So I will be starting with question number 1, and that's saying in the diagram below, the coordinate of D, E, F, and G are the vertices of a quadrilateral, right? F is a point on the x-axis. The diagonals of the quadrilateral bisect each other at K. The equation of diagonal EG is 3x minus y plus 6 equals to 0. So we are given this equation, right? We're given this equation, so please do not forget. And B and beta is the angle of inclination of EG. So let's try to determine, guys. I hope everything is clear on your sides. I hope everything is clear. And then please comment if ever you can see what I'm talking about, because I don't want to confuse people. They might think that, no, man, this guy now is giving us a hard time. Can't be able to see the question paper, but I believe the question paper it's clear now. So let me answer all these questions. So in this diagram, we are given the coordinate of D and the coordinate of G only, right? And please, people, do not be afraid of anything. Just apply what we taught you, right? So right now they're saying calculate the size of angle beta. The size of angle beta, right? Let me check out this. Okay. They want us to calculate the size of angle beta. In this case, they want this size here. They're looking for this size, right? So what to determine this size? How do we determine this size? We know that the equation of EG is given, right? So we are going to use the equation of EG. So in this case, we're going to use 3x minus y plus 6 equal to 0. Okay, we are using this equation. Is the one that we are given for what? For EG. So in order for us to determine the angle beta, you need to know the gradient of this line, right? So now the gradient, we are to solve this. We are to make y the subject. So y, it is equals to negative 3x minus 6, and then you multiply both sides by negative, so it's to remain with y. It is equals to 3x plus what? Plus 6. Therefore, this is the equation now. This is the equation of EG, right? by making y the subject of the formula. And then from this part now, you can do what? Now you can write the gradient of the line EG. So the gradient of the line EG, it is equals to 3. Now you can determine the angle of beta, right? The angle of beta in this case, it's tan beta, which is equals to 3. Okay. Now you can use your calculator to determine angle beta, right? To determine angle beta, now you are going to use your calculator. You say shift tan. It's shift tan 3. And then we're getting 71,57. So this 71,5 what? 7 what? Degrees. So now we know this angle, right? We've already determined this angle of beta. Yeah. So let's move to the next question. The next question, they are saying, calculate the coordinate of f if the equation of df is x plus 3y, which is equals to 8. We have to determine the coordinate of f, the coordinate of f here. So to determine the coordinate of f, we're using the equation that we're given now, which is x plus 3y is equals to 8, right? Is the equation of what? Is the equation of df. So you will realize that f is the what? F is the x-intercept. So from this equation that we're given, which is x plus 3y, it is equals to 8. We are going to let y equals to 0, okay? So our y here, it will be equals to 0. So this will be 3, open bracket, 0, which is equals to 8, right? And then from here, you solve for x. So x, it is equals to 8. So the coordinate of f here, the coordinate of f is what? It's 8, and 0. Okay. Let's move to 1.3. Calculate the coordinates of E. To determine the coordinates of E, number more, this x and y, basically x and y, right? To determine the coordinates of E, it's easier. We can use the midpoint, right? We know that the midpoint of DF and the midpoint of EG are equal. So in this case, you're going to use the midpoint of what? Of DF. The midpoint of DF, we know that it is equal to the midpoint of E what? EG or GF. GE, I mean. Let me use GE. Okay? GE. So in this case, the midpoint of DF, this will be what? This will be negative 10 plus 8 divided by 2 and 6 plus 0 divided by 2. Okay, so these are your x1 and x2, y1 and y2, right? Equals to the midpoint of GE. The midpoint of GE is what? The midpoint of GE is 1 plus x divided by 2 is to 1. Is to 9 plus y divided by 2 in that order, right? So now what do? We solve for x and y simultaneously. So, or let me not say simultaneous, but we need to solve x and y. Solve for that. So it's minus 10 plus 8. Minus 10 plus 8, it's negative 2, which is negative 1. So here it will be negative 1. And 6 plus 0 is 6. Divided by 2 is 3. Okay? Equals what? 1 plus x divided by 2 and 9 plus y divided by 2. So right now you can just equate the x's and the y's. So now you're going to say 1 plus 1 plus x divided by 2, it is equals to -1. And then you solve for x. And 9 plus y divided by 2, it is equals to 3. So you solve for x and y. So this will be 1 plus x equals to -2. You cross multiply, okay? And then x will be equals to -2 minus 1, which is equals to -3. So x is -3. And then what about y? Our y, it will be what? It will be 9 plus y, it is equals to 6. 2 times 3, it's 6, okay? And then from this part now, you can just solve for y. Y, it is equals to 6 minus 9, which is equals to -3. Therefore, the coordinates of E is -3 and -3. Just like that. So you do not have to stress yourself, okay? This is what you need to do. But sometimes if you're told that it's a quadrilateral, to determine E, it's easy. You can just use change in x and change in y, okay? You can try to use this. Let me show you how we do it. Here you will name this your x1, your x2, x3, and x4. Okay, so this is what you need to do if you want to determine the coordinates of E. To determine the coordinates of E, you are going to say, instead of determining the midpoint, you can say x1 minus x2, it is equals to x3 minus x4, okay, right? And then now you're going to say x1 is -10 minus x, because x2 is x here, is the one that we want to calculate, right? And x3 is 1 minus x4, which is 8. So in this case, you're going to have -10 minus x, it is equals to 1 minus 8. It's -7, right? And then from this part, you solve for x. So -7 plus 10, you are getting what? You are getting +3. So you multiply by negative both sides, and then you remain with x, which is equals to -3. Easier. Do you see that? Very much interesting. To determine y, very same thing applies. y1, y2, y3, y4. Okay? So now you're going to say y1 minus y2, it is equals to y3 minus y4. Our y1, it's 6, y2, it's minus y, equal to 1, equal to y3 is 9, minus y4, which is 0. Now you can determine y. So minus y, it is equals to 9 minus 6. Okay, there was no need for us to include this 0, because 0 means nothing. So minus y, it is equals to 9 minus 6 is 3, and then you multiply by negative both sides, you remain with y, it is equals to -3. Therefore, the coordinates of E, it's -3 and -3. So that's how you can determine the coordinates of E, okay, the vertex E, because it's what we are given here and told that this is a quadrilateral. So if ever it's a quadrilateral, you can use this method, changing x and changing y, right? Or if ever you do not want to do this, you can use the method that we have been taught by your teachers, to say that if ever you're given a quadrilateral, the diagonal, the midpoint of diagonal GE and the midpoint of diagonal DF are equal. So you can firstly determine the midpoint of the diagonal DF, and then after that you equate to the midpoint of diagonal what? GE. So it's very easy. Let's move to the next question. The next question they are saying, here we need to prove, guys, we need to prove that DEFG is a rhombus. You can prove using two things, two methods here. The first method, it will be, since we were given the equation of this equation of DF, the equation of DF. Do you still remember the equation of DF? And then we were also given the gradient of GE. The gradient of GE. If we can prove that the gradient of DF multiplied by the gradient of GE, the answer is -1. Therefore, we have proven that this angle right here is what? Is 90 degrees. So basically, we need to prove that DF is perpendicular to what? To GE. Because these diagonals bisect at 90 degrees. So let's prove that they bisect at 90 degrees. So this is what you need to do, guys. You are going to say, since you are given this equation here, 3y is equal to 8 minus x, and then you divide both sides by 3, you remain with y is equal to minus x divided by 3 plus 8 divided by 3, okay? So I have rearranged this. It means you can write as -1 divided by 3x plus 8 divided by 3, okay? So now we know the gradient of what? We know the gradient of DF, right? The gradient of DF, it's negative. The gradient of DF, it is equal to -1 divided by 3. But the gradient of GE, we have already calculated. The gradient of GE, we know that is 3 from where? From the equation that we're given, right? So the gradient of GE, it is equal to 3. So let's try to multiply these two. When we multiply them and then we get -1, it means that DF is perpendicular to GE. So let's calculate. MDF multiplied by MGE. Let's see. MDF is -1 divided by 3 multiplied by 3. And the answer in this case, we're getting -1. Therefore, we conclude by saying our DF is perpendicular to what? To GE. Done. We have proven that the quadrilateral here, it's a rhombus. Thank you very much. But sometimes you can also say that DG, the distance of DG and then DE. You can calculate the distance DG and then you also calculate the distance DE. If these distances are equal, therefore, DEFG is a rhombus. The very same thing applies. If you can calculate the distance from G to F and F to E, and then you find that they are equal, therefore, DGFE is a rhombus. Thank you very much. Let's move to the next question. Question number 2. We are moving to question number 2, guys. We are moving to question number 2, and with this question number 2, in the diagram below, You are given the coordinates of A, coordinates of B, and C. And then you are told that at the vertices of a triangle, BC is produced to D. AC cut the y-axis at F. E is a point on the x-axis such that CE is perpendicular to x-axis. So in this case, guys, the diagram or the sketch, it has been drawn for you, which correspond with the statement. So now we are to determine number 1. Calculate the length of AC. Leave your answer in simplified said form. So in this case, the distance of AC, the distance of AC, it's A equal to the square root of what? The square root of 1 plus 2 squared, okay, plus 5 plus 1 squared. So I'm using positives here because -2, it was my x2. I started by saying this will be my x1. Even from the distance formula, I said 1 is the x1, -2 is the x2. So when I replace our x1 and x2, I just realized that the x coordinate here is negative. So I multiply with the negative from the formula. That's why I wrote plus here. 1 plus 2 squared, 5 plus 1 squared. Okay? And then from this part, you use your calculator. Let me use the calculator, the square root of open bracket 1 plus 2 close squared plus open bracket 5 plus 1 close bracket what squared, and then we're getting 3 square root of 5. So the answer here is 3 square root of what? Of 5. So that's the distance of AC. We are done with number 1, and then you get your 2 marks for doing that. We are done with this one. Done. Okay, let's move to 2.2. 2.2, they're saying calculate the gradient of BC. The gradient of BC, B to C. This was 2.1. Our 2.2, BC, the gradient of BC. The gradient of BC, it is equals to, our y2 is 4, y1 is 5, minus 5. Our x2 is minus 3. Our x1 is 1, which is minus 1. So it doesn't matter the position of your x and y, okay? You can start by saying this was my x2 and this was my x1, doesn't matter. So now the gradient of BC, if we use a calculator, you know you are getting 1 divided by 4, -1 divided by 4. So let me confirm here, negative was 4 no, we're getting 1 divided by 4. So this will be the gradient, okay? So after determining this gradient, now you are to move to number 2.3. Done with this one. We are done with this one. We have calculated this, and then you get your 2 marks as well. 2.3, calculate the value of y if B, C, and D are collinear what? Point. B, C, D are collinear points. And then we know that if we have a collinear if we have collinear points, it means that the gradient of BC, it is because the gradient of CD equals the gradient of what? Of BD. So in this case, allow me to use BC and CD. So you are going to say the gradient, since we are told that they are collinear points, the gradient of BC, it is equals the gradient of what? Of CD. So let me just use DC or BD is fine. I can use BD or CD. Anyhow, it's fine, right? So let me just use CD here. The gradient of CD. Right. So BC, we know the gradient of BC, it's 1 divided by 4 equals C. Now we are to substitute. I will start by using Y followed by 5. It will be Y minus 5 divided by 5 minus 1. So this will be 1 divided by 4. It is equals to Y minus 5 divided by 4, right? So since the denominators are the same, we just forget about them and then we equate the numerators, right? Because if we multiply by 4 both sides, we are getting rid of these 4's, right? And then remain with 1 is equal to Y minus 5. Therefore, Y will be equals to what? Y will be equals to 6. Y will be equals to 6, right? So you get your 3 marks for doing that, and 1 mark for the gradient of BC and the gradient of CD, and then you get another mark for equating the gradients, 1 mark for the answer, and then we're done with this question again. Let's move to 2.4. 2.4, they are saying if H is a point such that AH is perpendicular to BC, determine the equation of AH. Perpendicular line. If we're talking about perpendicular line, know that perpendicular lines, they form what? They form a 90 degrees angle. I'm looking for a ruler here so that I can just construct the line of AH so that you guys can see what I'm talking about. Unfortunately, I can't find the ruler here. Ruler. Okay, no, it's fine. Even if there's no ruler, it's fine. Even if there is no ruler, it's fine. I will just use a pen, okay? What I'm trying to say is that they are saying we need to determine the equation of AH. So, if H lie here on the straight line, what? BCD. Since they are saying the AH is perpendicular to BC, so it means we're going to have something like this, perpendicular line right there, right? This line is perpendicular to BC, right? So therefore here it will be H, okay? It will be what? It will be H. So we know that this is 90 what? It's 90 degrees. It's 90 degrees, this part here. So since we know that it's 90 degrees, it means now we want to determine the equation of AH. So to determine the equation of AH, we know that A to H, the gradient of AH, it's what? It's, let me just write the 2.4. The gradient of AH, since we know that the gradient of BC, it's 1 divided by 4, it means the gradient of AH will be -4, because we are told that AH is perpendicular to BC. So if we multiply the two gradients, we're getting -1. So in this case now we're saying the equation will be in this form. You are going to use, let me just calculate the value of c. Y is equals to -4x plus c. So we're going to use the coordinates of a here because it's what we have through this line AH. A, it's -2 and 1, so y is -1 is equals to -4 minus 2 plus c, and c will be equals to -1 minus 8. Okay, so this will be minus, we're getting -9. So therefore the equation in this case of 2.4, it will be y equals to -4x minus 9. So this is the equation I'm talking about. This is the equation I'm talking about, right? We have already determined the equation, and then we are done. You get your how many marks? You get your 3 marks. 3 marks for that. 1 mark for the gradient of AH, another mark for substitution, and another mark for calculating y. Right? So the equation is in that form. 2.5. Let's move to 2.5. Calculate the coordinates of G. If C, B, A, G in that order is a parallelogram. Okay, so they're saying C is this one, B is this one, A is this one, and then G, if ever they're saying it's a parallelogram, it means we're going to have a line. We are going to have this line here. We are going to have a line like this. So this will be G. This will be G. Right. So if this is G, it means now we have what? We have our parallel what? We have our parallelogram. This will be a parallel what? A parallelogram. Okay. So we need to do what? We need to calculate the coordinate of G. The coordinates of G, which is x and y. But with this G, we know that y is 0, okay? We know that y is 0. So if you know that y is 0, it means you have to determine your x. You need to determine your what? Your x. So in this case, I have already taught you how to determine. So this is what you can do. You are going to follow this order, right? This is what you can do. Let me use this paper here. So you are going to say x1 minus x2, it is equal to x4. x1 in this case will be -3. -3 minus -2, it is equal to 1 minus x. Therefore, now you can determine -3 minus 2, it's -1, okay? -1 minus 1 equals to -x. So x will be equals to 2. So the answer here is 2. And then we move to y. But there was no need. But we can try to show that y is 0. y1 minus y2 is equals to y3 minus y4. y1 in this case is 4. -1 equals to 5 minus y. So this, we are getting 5. It is equals to 5 minus y. So 5 minus 5, it is equals to -y. Therefore, y, it is equals to 0. So that's how you can determine the coordinates of G. All right. We are done with this one. We're done with this question. And then we are moving to 2.6. 2.6, that's where you need to determine we need to determine the area of CEOF. We need to determine the area in this case. This is basically 2.6. 2.6, okay? They are saying CEOF, this party. Let me use a different color, We are looking for the area of this CEOF, the area of this part. Okay? So if we are looking for the area of this part, now we can draw a perpendicular line from EF. We draw a perpendicular line, right? And you know that this will be 90 degrees. Okay? So if we know that this will be 90 degrees, and then we know the coordinates of F, the line AC, the equation of the line AC. So F, in this case, we know that it will be 0, 0 and 3. 0 and 3. And we know that, let me just produce any letter here. It can be, let me use I. Okay, it will be I in this case. So with the I, we know the coordinates here. Here it will be 1. Even the coordinates of E, it will be 1 and 1 end. So you know that from 0 to this point is 3. From O to E, O to E, it's 1 and what? It's 1 and 0. Okay? Yeah, it's 1 and 0. So now, to determine the area, you know that you are going to use area of CEOF. It is equal to half base times the height, right? So in this case, we are going to use our base here. Our base in this case, it will be EC. Our EC multiplied by the height. The height in this case is what? Is OE. Okay? Or let me say OE, OF, because the distance from O to E is the same distance from O to F. Okay? Same applies to O to I. So you can use OE multiply by what? No disconnect. No disconnect. Network is a problem. Network is a problem. I'm really sorry for that. Just use your calculator, find this, and then you write the answer. That will be the answer for the area of CEOF. Okay. This one, even though we do not include this one, it's fine. You can just say half base times the height. Okay? Yes. Our height is OE. O to E is the